Good afternoon and welcome to the new Future of Cyber webinar series from the Surrey Centre for Cybersecurity. In this, the first of the series, we'll be looking at the impact that the pandemic and a year of lockdown has had on the world of cybersecurity. I'm Andrew Rogoyski, part of the Innovation Strategy team at the University of Surrey. For those of you who are not familiar with Surrey University, I just wanted to cover off a couple of things. We're a successful and influential research university situated in the town of Guildford. Originally founded over 100 years ago, the university started actually in Battersea in London, moving to Guildford in 1966 when we got our Royal Charter. We're about 16,000 students strong, 3,000 staff. We have three main faculties: the Faculty of Arts and Social Sciences, the Faculty of Health and Medical Science, and the Faculty of Engineering and Physical Sciences, which is where the SCCS, the Surrey Centre for Cybersecurity, and other notables such as the 6G Innovation Centre and the Centre for Vision, Speech and Signal Processing reside. So the Surrey Centre for Cybersecurity was founded several years ago, pulling together cyber-related research from across the university. It's gained recognition from the National Cybersecurity Centre, part of GCHQ, as an academic centre of excellence for both research and teaching. One of only 5 universities in the UK to have both certifications. You can find out more if you're interested from the website at surrey.ac.uk/SCCS, and you should have access to our new brochure, which covers some of the areas in more detail. Throughout the session, we'll be encouraging you to ask questions in the Q&A channel. So please put them in. We'll collate these and ask the panelists at the end once we've gone through all 3 presentations as the last part of this session. It now gives me huge pleasure to hand over to our Chair and Director for SCCS, Professor Steve Schneider.
Many thanks, Andrew. So I'm Steve Schneider, Director of the Surrey Centre for Cybersecurity. So I'm delighted to be welcoming you all to this first event in our Future of Cybersecurity series. How the pandemic has changed the face of cybersecurity. So our first speaker today is Giles Chamberlin. Giles has been in the video conferencing industry since 1988. He's currently CTO of Pexip, a company he co-founded in 2012 and which floated on the Norwegian Stock Exchange last summer. He's got a particular interest in security in this domain. Pexip are currently working with the National Cybersecurity Centre to advise on security standards for video conferencing. So it's fair to say over the last 12 months have been pretty busy for him. So we're grateful he's taking the time to be with us today. So over to you, Giles.
So yes, as Steve was saying, I'm the CTO at Pexip. We're a Norwegian company. I'm going to work very hard to make sure that this is not a sales pitch on behalf of us. So I'm going to be anonymizing all sorts of pieces. But it's been an interesting year and has brought video conferencing very much to the highlight. So what I want to try and cover today is looking back at the history of video conferencing, particularly from a security point of view, and seeing what's happened there over the last few years, and then taking that forwards and looking on again to where we're going from there. So we're going to be covering the history of video conferencing, looking at the year video took off, and then what's being marketed for security in 2021, and then moving on from there to what you should actually be looking for in security in 2021 and beyond. Scary thing is that video conferencing is over 50 years old. This is AT&T launching the picture phone at the World Trade Fair in 1965. And I'm of about the right age to be the young lad on her lap, but we'll gloss over that one. Suffice to say that at this stage, security was not a key topic of conversation. And in fact, video conferencing wasn't a key topic of conversation either, until telecommunications improved substantially and we moved on to ISDN, for those of you old enough to remember that. Basically digital telephony, 64 kilobits per channel, complicated ways of bonding multiple channels together, and at last you could get enough bandwidth for an interesting video conference experience. This particular photograph is an early Tandberg Vision 10 system that was built for BT, which basically launched the company. One of the reasons for including it is the gentleman on the far right is on my board, so I'm very interested in embarrassing him in public wherever possible. So we'll let him cringe at that one. At this point, video conferencing was an extension to telephony. The security on the systems was exactly that on a telephone handset, i.e. basically none. You relied on the telecoms company, the telco, to secure the line. That was it. Really wasn't a considered area. And in fact, the history of security in video conferencing pretty much mirrors, although lags by maybe 10 to 20 years, that of the security in email. When email systems started, it was plain text. You could forge the from field with aplomb. Everything worked. And then we started having lots and lots of violations. And we end up with encrypted links to your email server, lots of spam and source authentication protocols. And it became more and more sophisticated. And videos following very much the same approach. Around the year 2000, ISDN was proving to be really difficult for video conferencing. Trying to actually get the call up, getting all these lines bonded together was a nightmare. And there was this new thing out there called the internet. And internet bandwidth was starting to improve and even approach that you could get on ISDN. And so companies started to make hybrid systems. This early, again, it's Tandberg, just use my history. This early Tandberg system had both ISDN and IP connectivity. It's a very careful publicity photograph because these are the old CRTs, 4:3 screen ratio you can see. They were huge and heavy, but they've carefully tried to make them look small and neat. The problem was, from a security perspective, we carried over the old telephony approach into the internet approach, the IP approach, which was, this is a telephone, you can place calls into it, you can place calls out from it, that's it. Then people started deploying these newfangled things called firewalls, which meant you couldn't place an IP call into a company because it wouldn't go through the firewall. And if you can't place a call into a telephone, that's a bad thing. But the solution seemed quite obvious. Most companies just move their endpoints out into the big bad internet, put them on a public IP address. What could go wrong? At this time, I was working for a company that was coming up with a very early version of what's called firewall traversal, getting voice and video calls through a firewall in both directions. And so I was trying to talk to customers and explain putting your endpoint out on the big bad internet is a bad thing. And I will confess that on more than one occasion, I telnetted into their endpoint in order to demonstrate why a public IP address was not good. But again, the fact that these devices had a telnet port open, I think speaks volumes as to the approach to security at the time. But we move forwards, and ISDN is now, I was going to say abandoned. We actually had a customer come in recently we had to install an ISDN gateway for. But in general, all of the voice and video that's been going on for the last 5, 6, 7 years is on the internet. The problems of getting voice and video calls through firewalls using our standard protocols have basically been solved. We have standards in there to solve all of that. And all would have been wonderful. But as this slide shows, for a while, video was very much the boardroom darling. You had a huge, expensive system used only by senior management. Most people could never get their hands on it. But computer power started increasing. Laptops could start hosting video calls. There were some early versions around that were really quite usable in 2005, 2006. and it's just improved massively ever since. I'm currently on a laptop talking to you guys. So the democratization of video was fantastic. Everybody could have access to it, but that started bringing in interesting other problems. To make life more interesting still, we had last year. Everybody was trying to work from home where possible. This meant a huge increase in video conferencing usage. All of the video conferencing providers had a massive increase in scale. We all wobbled a bit. There were a lot of late nights worked by people across the various different companies. I'm really proud to say that we all held up in some form or other. And given a tenfold increase in usage, more or less overnight, I think that's really quite important. But on the other side of the house, the end users were finding whatever they could to carry on with their work. Security was definitely not top of mind. More important was, could you get that last webcam off Amazon, because they were all selling out big time. And that caused a few issues. You may have come across this video on the internet. A somewhat unfortunate lawyer in the States, I think he'd let his children use his laptop for a Zoom meeting with their friends or whatever. They had installed a cat filter, which transformed our lawyer into the character in the bottom right, and led to the immortal quote, "I am not a cat." Now, it doesn't initially look like a great security issue, although from an authentication point of view, the statement, "I am not a cat," is on the weak side. But if you look at the frame top left, recording of this hearing or live stream is prohibited, and then various penalties beyond that. And this video is all over YouTube. So from a practical point of view, okay, not much has been leaked. It's not really a problem, but the protocols of this district court totally violated, and the statement, "You must not record this," obviously ignored. Slightly different, but similar sort of problem. Parish Council in the UK recently managed to get itself all over the internet after a meeting got a little bit noisy. The chairman of the meeting, Brian, highlighted in green there, stated forcefully that "you have no authority here" to the parish clerk, as she was threatening to throw him out of the meeting. And apparently, according to their house rules, the only person who could eject anybody from a meeting was the chairman, Brian. Unfortunately, the meeting was being hosted by the parish clerk, so she just kicked him out of the meeting. So we have a discrepancy between the official rules of engagement and the practical rules of who's got the eject button. So again, security issues coming in without consideration as to how they could play out. In this case, made for an interesting internet meme for a while, but in alternative areas, it could be very embarrassing. And then something often called Zoom bombing, which is a bit unfair on Zoom. And in fact, this particular example, I'm going to hold my hand up to because it's our product that was being used. The EU defence ministers were holding a meeting. One of them was self-isolating at home and wanted to prove that she was working. So she tweeted a screenshot of the meeting, which happened to include her joining credentials. The gentleman in the middle on the left-hand side there is a Dutch journalist who saw the tweet and joined the meeting. Everybody was very polite and good-humoured about this, and he left shortly after. But again, not a good thing if you've got somebody joining a high-level political meeting like that who's not meant to be there and is not even wearing a jacket and tie in that case. And there were lots of examples of this. a lot less salubrious over the last year or so. My children have been in remote learning, like I'm sure many of yours have. There have been cases of people publishing their credentials on the internet and asking friends of theirs to break into the meeting, disrupt them, make the lessons slightly more exciting for them. So there's been lots of difficulty around there. So we've seen this mass rollout of video cause some real exposure of security issues. But let's put that to one side for a moment. And let's look where we've been going on a security and marketing on a lot of these products recently. Partly because of this increased engagement, security's become, or the illusion of security, has become a key buzzword in the marketing literature, a tick on requests for quote lists, do you support this, this? And a lot of it is noise without sort of stepping back and looking at the fundamentals as to what's going on. Couple of examples of that: end-to-end encryption, as used on WhatsApp and so forth, was highly touted by one company. Turned out they weren't doing it at all. I think the marketing department had misunderstood what was involved there. And so that caused a bit of embarrassment. There's been a scrabble. They now support end-to-end encryption in some scenarios, but they can't authenticate who you are encrypting to. And there's another company now coming out again with big statements about we will support end-to-end encryption. When you read the fine print, we will support end-to-end encryption in this tiny scenario. The rest of the time, not. And by the way, by default, we don't do encryption anyway. And then when you get into encryption, you see people waving around, oh yes, we support AES encryption, which sounds great. It's the gold standard of practical encryption methods at the moment, required by all the big government agencies. Great, tick. What more do you need? But again, look at the fine print. And at this point, it's really hard to look at the fine print because you have to be deeply interested in this sort of stuff to dig into it. But AES supports lots of different modes. Some of them are older than others. There's one mode called ECB, Electronic Codebook, which is now deprecated. I think if you were in one of Steve's security lectures and you proposed using AES with ECB mode, you'd get a failing grade for your lecture course. The reason is, if you encrypt an image using AES with ECB, the central frame there is showing what that encrypted image looks like. And I think it's reasonably clear to see that you can still make out the penguin, you still know more about what's going on than you should. Change that ECB mode to one of the more modern modes, such as CBC, and you end up with the pseudo noise on the right-hand side, which is what you should be getting. So the point here is not the detail of what encryption algorithm should you be using, just that cryptography, security is hard. Taking a quick stab at putting something in just to get the tick on the sheet might mean you miss the underlying fundamentals. So security has to be front and center of the product that's being developed and has to be a first-class citizen of the feature list of that product. Otherwise, you end up with people taking shortcuts, and that just hurts. So with that bad news about what's going on and how hard it is to actually get to the bottom of what you should be doing, what should you do? And at this point, it's step back. Don't worry about the deep technologies involved. Think about what you're trying to achieve. What data is at risk in your video conferencing solution? Very possibly call data, call metadata. In this particular one, you could go to the logs of the service provider running this and see that I have called into this meeting. I called in at this time, I stayed here for this long, and these other participants were in. That metadata for my Sunday evening call with my friends and a glass of wine, is not a problem. I don't particularly care if that gets spread out. It's, yeah, fine. If I was the chairman of Coca-Cola and I was recorded as spending a lot of time talking to the chairman of Pepsi Cola, then people might start thinking, oh, is there a merger? Is there an acquisition in prospect here? Maybe. And so that metadata suddenly starts having value. Maybe we need to protect that. So you need to consider that and see if that's a problem for you or not. And you also get things like GDPR coming in there as well. The metadata will very likely contain personally identifying information. How are you going to handle that? And considering all of those. And then there's the data in the call. How much of that is being handled by your service provider? If you're getting subcaptions on the text, that means they're doing speech-to-text processing, which means they've got access to the audio data. Is that a problem? Are you concerned by that? Again, you may not be. You may trust your service provider implicitly, which is fantastic, but you need to consider these things and see where it's going. And then if you were to be breached, if that information were to leak, what's the impact of that? Does it matter? Again, my Sunday evening social calls, yeah, that's fine. The Coca-Cola and Pepsi merger, yeah, that's got a high impact if that's breached. Then you get to the ease of use versus security bit. And this is something where a lot of video conferencing suppliers have struggled, particularly over the last year, where we've had a huge influx of new users. They will never change the defaults. They're happy enough that they can get their camera connected, their microphone connected, and everything working. If you've got to go in and turn on encryption as a specific setting rather than transmitting your audio and video in the clear by default, that's never going to happen. If you've got to go in and set a PIN code to allow entry to a meeting, most people are not going to bother. They're just going to let everyone call in. So you've got to consider where your defaults are to make it easy to use, and then also how far you want to go down the process of making the system harder to use, but make it more secure. At one extreme, we have customers who've decided not only do they not trust us as a service provider, they don't trust the internet, so they bought our software, they've installed it air-gapped from the internet in their own data centers. The particular customer has no shortage of scary-looking armed guards available who ensure that data center is secure, and they run everything under their own control. They know that metadata can't get leaked. They know that any data that's recorded in the call cannot be leaked. They're happy with that one. But they've got the downside. They've got to run their own system. Another example of security versus ease of use. One of the companies that's doing end-to-end encryption, as I mentioned, can't authenticate the users that they are encrypting to. Their suggestion in their latest white paper is that you transmit a 23-digit checksum to each user out of band to verify the encryption keys in use. That's an added complexity. So if you don't need the guaranteed security of that, you're not going to go down that route. And then the final piece, which is stepping back and saying, who's the threat? What are you actually protecting yourself against? Are you worried about nation state actors? In which case you've got a huge number of problems. And yes, maybe the transmitting 23-digit keys is a good thing to do. If you're just worried about somebody gate crashing your meeting inadvertently, maybe just lock in the meeting room before you start talking about the redundancies in your company or whatever. It is a good route to go. So summing that all up, I think it's fairly clear that video is going to remain a core piece of collaboration technology going forwards. In fact, it's going to be more than that, I think. Now, as we've all been working from home for so long, as we go back to the office, it's going to be at a slightly reduced rate, I think, to the way we were working before. A lot of people will say, oh, can I work from home today, please? So you're going to have meetings where half of the people are in the meeting room, half of the people are on video at home, some will be on posh boardroom systems, some will be on a laptop in the kitchen. So that's going to remain there, and we've got to adapt to using that. So when you're evaluating a solution, don't just look at all the shiny features. In fact, some of those shiny features might actually be a handicap in the way you're intending to use it. I think the key example there would be the cat filter. Not something you're going to need in most business situations, and it's something else you can shoot yourself in the foot with, so avoid. But what you do need to try and consider from the very beginning is security. Trying to bolt that on afterwards, either by changing your requirements of what your users have got to do, or suddenly seeing that your solution no longer fits your security requirement and you've got to swap it out. That's painful. So think about it from day one. And in order to think about it, you've got to step back and look at the risks and your risk appetite and see where you want to go with that. And that's really my view, my thoughts on video conferencing and security in this brave new world that we're in.
Okay, well, many thanks, Giles, for a great overview of some of the security issues and underlying video conferencing that you have to worry about. I'm pleased to welcome our next speaker, Eerke Boiten. So Eerke is a professor in cybersecurity and director of the Cyber Technology Institute at Montfort University in Leicester, as well as head of School of Computer Science and Informatics. He works in the area of cybersecurity and privacy with a particular interest in the policy sides of data, frequently appears in the press and in debates on privacy. Last year, he organised a public letter signed by more than 200 academics expressing concern about privacy in the contact tracing apps that were being developed by NHSX at that time, a topic he'll be talking about today. So over to you, Eerke.
Thanks very much, Steve. Thanks for that introduction. I'm going to talk about the topic, general topic, how pandemic has changed the face of cybersecurity, and concentrating on the sacrifice of privacy as we've seen it in the UK. And that sounds a little bit provocative, maybe, but you'll get the essence of why that's the point here. And apps and data stores are two of the areas where we've seen something happen. And I will ask at the end, was it worth it? Have we got out of this what we needed to? So yes, as Steve already mentioned, Cyber Technology Institute at Montfort is an academic center of excellence in cybersecurity research, just like the Surrey one. And so to start with, when we wrote this letter and we went into the press with it, some of the pushback we got was along the lines of, yeah, but you're looking at privacy at the expense of human lives and things like that, right? And that's absolutely not the case. In fact, we know that privacy is not an absolute thing, right? If you look at the Universal Declaration of Human Rights, you will see that privacy is only mentioned in the context of no arbitrary interference. So interference is okay as long as it's not arbitrary. So privacy is not the primary thing, not an absolute thing. And if you look at the GDPR, and I'll come back to GDPR data protection law now and again in this talk. You can see that the processing of data concerning health is in principle prohibited because it's special category data, as it's called, and then the exceptions follow. And one of these exceptions is number 2I, which says when it's necessary for reasons of public interest in the area of public health. Well, I think we were there, right? We are there. So. We've had a fantastically interesting year, as Giles already mentioned, in the context of video conferencing. But it was the first time that we had a couple of things happening at the same time. So some of these things were slow in the making, but the combination of all was new. So we have ubiquitous large-scale surveillance from Google and Apple and everybody else, and some of that is a little bit self-imposed. We all carry our little surveillance machine with us, and sometimes we even make phone calls on it. Around that, there's a very highly developed surveillance capitalism ecosystem. So not just Google, not just Apple. There's lots of data going back and forth, and yeah, the world is attuned to doing surveillance, digital surveillance, and doing it in a way that some people make lots of profit from it, and there's lots of data going about, more than we're aware of. On top of that, we've got huge computing power in the world. So weather systems work these days at high precision and high information. And in general, we've got the computing power there. We can deal with millions of data points and maybe trillions or billions. I mean, I'm not really a high performance computing sort of person to say exactly how many zeros there are in that particular line. But lots and lots of data points, and we can deal with them in real time. And then, yeah, okay, some of what I'm saying here is a little bit tongue-in-cheek, right? So artificial intelligence, has it surpassed human intelligence? Well, at least at playing Go, which I would say is a complex task that involves a bit more than just doing brute large multiplications or whatever. And on top of that, of course, we've also got data protection law that's equipped with all of these, at least in theory. And on top of that, 2020 was the year in which, of course, we got a crisis which, in an ideal world, would require all hands on deck from all these things, gathering lots of data, processing it at high speed, doing clever things with this, and doing all that in a responsible way as well. So it was a perfect moment for all that to come together and produce something really fantastic. Did it? Did it not? Well, so one place to look at is, of course, the whole story of contact tracing apps that Steve already hinted at, that we could hit at it. So I would say the essence of contact tracing app is the processing of people's possible infection status at a large scale, the national scale. And then hopefully, well, we can't do it by hand. We have to take some automatic decisions to restrict individuals' movement. Namely, if we've decided that somebody's potentially infected, then we need to tell them to self-isolate. Right. So this is what a contact tracing app does. This is functionality. This is not. It sounds almost like legalistic language of describing something really bad, but no, this is a good thing. This is what collectively we decide. There is this thing called test and trace and whatever, which does need the right data input in order to decide, okay, it is too dangerous for us all now if this particular person moves about. Okay, you can put it a bit more legalistically. So it's the processing of health data, which GDPR says is special category, and I already mentioned it's prohibited to process this unless you've got a very good reason for it. It happens at the national scale. Well, the GDPR has things to say about large-scale processing, so it means that the need for representatives, which is less interesting, need for data protection officers, also slightly less interesting, and the need for data protection impact assessments, which is way more interesting, and I'll come back to. And there's the taking of automated decisions which have a significant impact on people's lives. So the Articles 21 and 22, which are about automated decision making, whether it's a good thing, whether people can opt out from it, and whether it's allowed at all. And I'm not even thinking about children here, by the way. And all of that to restrict individual autonomy. We're telling somebody they can't move anymore. So essentially, we're taking a very, very important right, the right of people to move about where they live, away from them, as a consequence of doing all this data processing and the decision making that follows from it. Whereas if you look at Article 1 of the GDPR, it says, well, we should protect people's fundamental rights and freedoms. So I think this, in a nutshell, explains why saying, well, you're trying to do this asking this contact tracing apps to be in a totally privacy preserving way, that and you're doing it at the expense of life. No, not really. We're looking at an application which is intrinsically an enormous breach of privacy, an enormous breach of autonomy, enormous amount of sensitive data processing. But it serves a purpose, and the sort of relative value of privacy means that it is a possibility that seriously needs to be considered. So in England and in the UK, we have some of the following players involved in setting up contact tracing, right? So we have NHS Digital, which has been called HCSC in the past, and has had other names in the past as well. But it's the branch of the NHS that deals with information governance on large scale databases, which has huge experience with it. You will find that privacy people have sometimes criticized them for being a little bit sloppy with giving data, maybe to the wrong people, arguments about whether data is anonymous or not. But roughly speaking, these are the people who take care of the NHS's data, and they know what they're doing, right? I've read assessments which said that actually in the COVID time they've upped their game in terms of information governance. Then there's NHSX, which is a Matt Hancock inspired new branch of the NHS, which is applying artificial intelligence in an NHS way in order to do innovation, transformation, disruption, and all those things which are not intrinsically good but sound flashy. Right? We have the National Cybersecurity Centre, which is a branch of GCHQ, if you like, which is interested in making sure that everything happens well with the critical infrastructure of the country. So that includes health. And then there's Public Health England, which was always responsible for making sure that a crisis like this, the right thing happens. So, and then there's some others on the margins of this. So the thing that happened was Public Health England ruled itself out fairly early on in the crisis, or was ruled out early on in the crisis. They proved their incompetence in terms of information governance by a downright ridiculous privacy notice for the test and trace system, which sank deep and had lots of deep problems in there, including talking about personal identifiable information, which is not a UK term. Sorry, the data protection nerd in me jumping up there. Sorry, there were worse things with that. The other player that was ruled out somehow was NHS Digital, which is sort of shocking. So what are we left with? Well, what we're left with in terms of the start of trying to do a contact tracing app in the UK was basically scientists from the Big Data Institute at the University of Oxford talking to NHSX and an organization whose purpose was to do stuff but not to achieve goals particularly, and to do stuff in a way that's innovative and I would personally call them happy clappy techno solutionists. So they talked to each other, and the Big Data Institute thought we need lots of data, and NHSX thought we want to do something disruptive here, and it might even be useful in the context of the crisis. And then there was the National Cybersecurity Centre, which fortunately was also close at hand in order to make sure that everything that happened here was as secure and as privacy preserving as it could potentially be. But how much privacy preservation can you get in a context where the people who are wanting the solutions are essentially hungry for data, because big data is what they do. So that was the scheme. There were some other players on the margins: Google and Apple, the Turing Institute, and of course some other companies as well. So we ended up with the English contact tracing app version 1, as famously or infamously trialed on the Isle of Wight in the month of May. So we had it was based, as all of these are, on Bluetooth. So Bluetooth signals bouncing off other devices between mobile phones. That gives a little, the return of those signals gives a little bit of an indication of how far apart people are or devices are, and that gives some measurements. And people at the National Cybersecurity Centre and people at the Turing Institute have done various in the way of trying to amplify the information in there and make the information in there more secure, more accurate. The NCSC provided security, and within the context of what they had there, as much privacy preservation as was potentially possible. As I said, big data. Anyone doing big data is hungry for data. So the Big Data Institute people were happily talking about 60% of people taking up this contact tracing app, and that would allow the whole country to operate as normal again. So we were talking about the country operating as normal again in April of last year, and we were hoping that the app could help for that. Clearly, we have not landed there. As I said, NHSX are techno-solutionists. They think technology will solve the problem, but they were not particularly experienced in data governance, and the party who was experienced in data governance with the NHS was sort of ruled out. The Public Health England had shown their incompetence. The whole test and trace thing, when the tracing app came about, was barely in the picture. Dido Harding was not yet in charge of test and trace at that point, and anything that people wrote about test and trace or wrote about the app was barely connected. The thing that came out of here was a centralized solution, i.e. a solution where mobile phones measure how close they are to other mobile phones and then send that data onto a central place, and the central place then does some analysis on who might be infected on the basis of all this proximity information. And there wasn't a data protection impact assessment on this available until the effort at White really started. So why did this thing fail in the end? There's lots of possible explanations for that, and I'll probably run out of time before talking about all of them in detail. So as already mentioned, there was a letter signed by 200 UK academics in computer science and law mostly. We said at the time, we need to know that this works for the privacy impact of a centralized solution to be worth it. And you need to give us a data protection impact assessment, which is a GDPR requirement, etc. in this sort of context, which would ask questions of proportionality, necessity, coverage of all the possible risks, and data minimization as well. Is it necessary to gather this much data? Is it necessary to do it centrally? Then the data protection impact assessment came out eventually, while the test and White were going on, and some people looked at it and said it was in a dreadful state. There were lots of issues in there. The NCSC, etc., hacking of the Bluetooth measurements made some oversimplifying assumptions. There were stories in the news at one point that the whole thing only worked on 2% of Apple phones. There's a socioeconomic bias in the whole thing, and that wasn't the reason why this one didn't make it. the socioeconomic bias is that these sort of things work very, very well on the slightly more expensive phones, whereas the people who can afford slightly more expensive phones, broadly speaking, are the people at the highest risk of COVID infection, because they do jobs that involve more travel, more public transport, being closer together in small spaces and things like that. Whereas the well-off comfortably can work from home, like us and university people have been doing. In the context of all this, it was all about finding infected people, but Matthew Gold, who was in charge of NHSX, and Ian Levy of PCHQ in various public meetings and writings, came up with all sorts of other useful uses of the data collected, which was against sort of purpose minimization ideas, function creep. Meanwhile, Zulke, on behalf of NHSX, explored a decentralized solution more in line with what other European countries were doing, and in line with the Google and Apple provided interface. I mean, Google and Apple quickly jumped in because they saw the world was creating a surveillance infrastructure that they weren't in charge of. So yes, they came up with their own solution, as people probably know, but that solution didn't work well with what the NHS and NCSC was developing there. So that has been posed by some as a sabotage. And the testing and tracing system wasn't actually equipped to take any data from the contact tracing. So lots of things that might have caused it to fail. I think I'll probably run out of time if I tell you also about the datastore, which is being run by some companies with close links to the current government and its advisors, where lots of data is being collected. We don't quite know what it will be used for, because the data protection impact assessment that exists says we need all this data, we need to have all this data, and this is about having the data. So having the data is the right thing, and that's the right purpose. But nobody talks about what happens to the data there. So that's a little bit dubious, especially now the contract on this data store with Palantir has been expanded beyond, well, we hope what's beyond the crisis. So in conclusion, have we successfully sacrificed privacy here to solve COVID? The sacrifice would have been justified in principle, but we don't really know. If you look at the figures that Christopher Fraser produces on the effect of the app versus the data that people like Spiegelhalter look at on the overall effectiveness of testing and tracing, then it can't have made that much of a difference. It probably hasn't avoided the 640,000 cases. There's been a big failure on transparency, which the transparency of data protection impact assessments and in general would be required in this sort of situations. If we're doing more with people's data than normally, we should be more open about it. I haven't seen the AI at work. I have seen no sight of intelligent data-driven interventions. Put it more politely. And on the positive side, the decentralized app that version 2 eventually became had a minimal privacy impact, and it has some brilliant features. But on the other hand, lots of data has also gone to Palantir Factory and that sort of companies with very little effective oversight, either from government and opposition or from the central data protection oversight. So overall, I think no, we've not. The potential was there for something where an enormous amount of privacy was sacrificed for exactly the right reason to gain spectacular results. But it clearly hasn't happened. Okay, I think that's the point to stop.
Okay, well, thanks very much, Eerke, for a very engaging and thought-provoking talk about the recent past, and I guess things are still ongoing. So I'm now pleased to introduce Nishant Sastry to give our final talk. Nishant is a professor at the Department of Computer Science here at the University of Surrey. where he's co-lead of the Distributed and Network Systems Group. His expertise is in internet data science, focuses on both network infrastructure and on social networks and the relationship and interplay between the two. He's regularly in the media and also works with public bodies such as UK Parliament, Wikimedia Foundation and the Samaritans on social and public policy. Today, he'll be talking about web privacy and how it's being compromised. So over to you, Nishant.
So I'm going to talk about a study that we've been running for the past couple of years. It started with when GDPR was being introduced, and we sort of wanted to figure out, does GDPR actually make a difference? And what we managed to do was set up a way to track how people were being tracked. So that's why the title, Tracking the Trackers. And what we're mainly focusing on is these kind of third-party trackers. And it's now, since then, grown into a multi-country study of third-party web trackers. And as far as we know, this is the largest such study. There's several thousand users who are using our Chrome plugin, which we have released in the wild. So this is results that I'm going to present from these, of the several thousand users. Over 700 of them have kindly agreed to donate their data in an anonymized fashion. So this is a result that follows from that data. So I would expect that most of you sort of have an idea what I mean by third-party cookies, but just a brief explainer in case any of you needs one. So suppose a user goes off and visits a shopping website such as Argos. And then they may go off to a news website such as The Guardian. As we probably all know, each of these sites, such as Argos, would place a number of cookies in the user's browser. And so would a site such as The Guardian. But what's interesting is that over the last, let's say, 8 to 10 years, techniques have been developed by advertising agencies, by performance analytics agencies, and so forth, that actually track this, that actually transfer these cookies, information from these cookies from one website to another website. And the way they do that is basically there might be a single third party, such as Google's DoubleClick, which is its way by which it delivers ads, targeted ads, which may be present both on Argos as well as on The Guardian. And this kind of third party then connects the first parties together. And so that means that information is leaked from one website to another website about the user's browsing history without the user actually agreeing for such things to happen. So why is this important? We did a study on news websites in particular, and this was focusing mostly on the US. And what we did was we basically construct a bunch of personas. So you could go off and visit a bunch of websites that. Let me just start my laser pointer as well. So you could visit a bunch of websites for men or for women and so forth, and seniors or a combination of personas. So a youth who is also a male and so forth. And once you visit these websites, you're building up a persona that the third parties can use to sort of track you. And what we find is that some of these, depending on which website it is that you're talking to, there might be some websites which are interested mostly in women, or there might be some websites which are interested solely in seniors. So if you happen to be one of these demographics, then they actually land more cookies that track you more intensely. And why are they doing this? They're doing this because that allows them to charge a price. This is the price of the ad that is charged. So by doing this kind of tracking, they're able to monetize these users more effectively. So that's sort of the background on why this is important and what is really happening on the ground. So let me then give you a short introduction to the plugin that we have deployed, and anyone can install it. The URL for this is tiny.cc Lightbeam Chrome plugin. It's called Lightbeam because there was a similar plugin for Firefox that we had to adapt and improve upon to come up with this plugin. And the plugin on Firefox is called Lightbeam. So let me play this video so that you can hear it in the words of my PhD student who has been doing much of this work.
The first time you visit and install our extension on Chrome Web Store, it will provide you a very clean browsing history because we will not require any previous cookies from your site. Then you might visit some news website like theguardian.com. So the first party website will be served at the round circle in the middle. And then all the third-party trackers are served at the triangles around it. Then we back to twitter.com, and we could notice there are two interconnections are built between these two first-party websites you visit, twitter.com and theguardian.com. If you also do some shopping behavior on Argos, more and more interconnections will be built across 3 different first parties. So the more first party you visited, the more interconnections will be built on your background. Apart from that, imagine I'm a user from another country like China. We might use Baidu instead of Google. And surprisingly, the Baidu.com will serve as a very independent ecosystem apart from those UK popular websites. So we keep accessing some popular websites in the China, like some news website and shopping website. So after a few seconds we've spent on this website, we back to our extension and notice the popular website located in different countries will develop to separated third-party cookie ecosystem.
Okay, so that gives you a little bit of a sense for what our Chrome plugin does. So essentially, it keeps track of which first-party and third-party website cookies are, which first parties you visit and which third parties place cookies on those first-party websites, and creates a network among these different users. So from this, we create something called a first-party interconnection graph. And the idea really is we wanted to somehow characterize across the different countries, across different kinds of users, to try and understand how is it that people are really being tracked, and can we quantify the level of tracking, whatever that means, right? So we need to come up with a way to quantify what tracking means. So the key to this is really these red triangles there, which are basically the interconnections, in this case, between Guardian and Argos. So if you take that, you will find that all of these first-party websites can be considered as one layer of a bipartite graph, and the third parties that are associated with them can also be linked using these kinds of edges that you see here. So from this kind of a graph, we can then extract another graph such as this, and we can do this for each individual user without noting, in an anonymous fashion. And what this does is this basically connects, let's say, Google and Argos are connected because they have a connected third party in this case. And if you do this across all of the websites that a user has, then you'll notice that that a graph like this tends to form, which we call as the first-party interconnection graph. And the idea is that maybe some characteristic of this graph can be used to quantify how the privacy of an individual user is being leaked. And then if you aggregate that across all of the users from a particular country, you can say which user, which country is worse and which country is performing better. So how do we look at this? So if you look at this, really speaking, what we want to do is we want to look at what kind of fences do we need to build in order for these information leakages to be stopped. So in this case, for example, between Argos and Guardian, you need to form a fence because they do share some third parties, and therefore information is being leaked. Whereas between Baidu here and Argos, there isn't any information being leaked. There isn't similarly any information being leaked between Facebook and Argos, because there is no direct edge between them. So, so by looking at these edges, and rather looking at the lack of edges, you might be able to figure out how to interconnect them, or how interconnected these different graphs are. And so an analogy to this is, really speaking, so that if you're able to color these different nodes in a graph, and it's similar to coloring different states in a map, where you want to actually color adjacent states in different colors. So in essence, you want to be putting Argos in one color and all its neighbors in different colors from Argos. But you can put Baidu in the same color as Argos. You can put Facebook in the same color as Argos. So if you do this, you'll find that in this case, for this particular user with these particular websites visited, you can color this graph in 3 colors, and therefore the level of interconnectedness somehow translates to the 3, because that's the number of different fences that you need in order to keep this graph interconnected, disconnect this interconnected graph. So what you see is that you are able to put all of the different sites with the same color within a single container, within a single fence, and all of the edges are crossing these containers. So if you make sure that these containers do not leak information, then you don't have information leakage happening. Apologies for this. I don't know why it seems to be automatically advancing the slides for some strange reason, which is causing a little bit of a problem here. If you look at this from a graph theoretic perspective, that number, the number of colors that you need for the graph, to color that graph, is something known as the vertex chromatic number of the graph, which is, in this case, a measure of how tangled your web browsing history is. And therefore, we call it the tangle factor. So we use the tangle factor, which is the number of different containers that you need, the number of different fences that you need, as a way of quantifying how much privacy is being compromised. So one way to think about these different fences is to use either different browsers, or you could be thinking about using something like Firefox, which has multiple containers. And the way each Firefox containers works is basically they create different personas, different cookie jars for each of the different containers, which means that you could have a separate container for your personal web browsing history, a separate container for your work browsing history, separate one for your banking, and so forth. Of course, this is how it's being branded or marketed by Firefox, but this may not necessarily be the best option for you from a privacy perspective, because it could be that multiple different websites within your personal container are all still able to share information. So really what we want to be doing is not these manually created containers, but automatically create those containers, as we saw in the previous slide, where you're looking at the edges that are being formed by the third-party interconnections, and then creating containers to separate those websites which are sharing information across different websites. So with that, what do we find? As I said, we can use this at an aggregate level to look at how real browser histories are compromising, how privacy is being compromised on real browser histories. And we can aggregate those across different countries to look at how privacy is being compromised between countries. So one fun example here is that we looked at UK and China was an immediate thing to look at, because my student who was working on this is Chinese, so she had a natural interest in looking at the two countries that she is very familiar with. And to our surprise, what we found when we looked at a whole year's worth of data was that actually UK was performing worse than China. So there's more privacy leakage happening here in the UK than in China. This is not what we were expecting. We looked at it in a little bit more detail because obviously you're going to have different sets of users. You might have some users who are heavy users who are looking at lots of different websites, and therefore maybe their privacy is more easy to compromise. Whereas there may be other users who are much more lighter users, and therefore their privacy is being preserved better. So it really is the case. So what we find, we did a regression here, so you can see that you could think of let's look at someone who has accessed about 200 websites here, right? And if that person happens to be in China, then the number of fences they need, the number of different containers you need for that is lesser than if that person were in the UK accessing UK-based websites. So what we are finding is that, as you might expect, heavier users tend to require more number of containers, more fences. But overall, there's the loss of privacy is happening faster in the UK as you go and visit more and more websites. You lose privacy at a faster pace in the UK than in China. Turns out that the answer for this, the reason why this is happening is really because China, the Great Firewall of China, blocks out two very, very important entities. It blocks out Google, it blocks out Facebook. And these two are some of the most important and widely prevalent trackers in the Western world today. And just by the virtue of blocking these two major companies, Chinese users are being protected, and the privacy of Chinese users is being protected, which is ironic considering the real purpose of the Great Firewall of China. Well, so we can also look and see how has tracking changed or has tracking changed in and during the pandemic, because this is a continuous study that's ongoing. And what we actually find is that, yes, in fact, it has changed, and it has changed for the worse. The number of third parties has almost uniformly increased. It has almost uniformly increased across every category of websites, ranging from adult websites all the way down to the sports websites, as you can see here. It's increased in almost every single country that we have a significant number of users for. So basically what's happening is that as we have all started to work from home, as we are starting to use more internet from our homes, and as we are starting to do more and more things online because we can't do them in person, the level of tracking has also increased. We can look at it in a little bit more detail, and we actually broke it down based on different countries and when they had their lockdowns. So we make a distinction between before the first lockdown, during the first lockdown, after the first lockdown, before the second lockdown, during second lockdown, and so forth. So if we divide the time duration between, let's say, last March, actually last January, or somewhere during January is when China sort of introduced its lockdown, I think. And that was the first country to introduce a lockdown, a national level lockdown there. So what we find is that there's an increase. The most of the increase actually happened during the first lockdown itself, and it sort of stayed at that higher level of tracking even after the lockdowns ended. Which is, if you're a little bit cynical, perhaps not an unexpected thing to have happened, right? And also interesting to look at is where this is the highest increases were. The highest increases happened in the categories of health, not surprising considering COVID. It happened in the category of home-related websites, again, not surprising considering we're all working from home and pretty much confined to our homes. And worryingly, it's also happening for kids-related websites, which may be a side effect of the fact that kids are spending more time online. They're not able to go to schools and so forth. So it's a rather worrying picture but it's basically suggesting that these third-party players that are taking advantage of the fact that we are spending more and more of our lives online, and so therefore we actually do need to find a solution for this. So I'll sort of stop there. There's a bunch of papers that we have written on this in the last year or so, and appearing in conferences like the Web Conference, IEEE Euro SNP, and ACM Web Science, which you can also find on my website as well. I'd like to conclude by having these links here, and the first one is a link to the plugin that we discussed, Lightbeam. We also have a data explorer, which I'll show you very shortly. And then the final one is actually a new cookie manager, is a new extension that we have just built, we have released. It's got a few users now, but it's still early phases. So we're calling it Rachel's Cookie Manager because what it does is it automatically sets your GDPR cookie consent. So it lets you, so when you visit a website, GDPR requires a cookie consent banner to be shown. Most of us get fatigued, and we had a previous paper in Web Science in 2019, which showed that GDPR actually has not changed the number of third-party cookies, because most people simply pick the default option and say accept all, and then they end up being tracked. So they're giving their consent to being tracked because they can't be bothered, or they're fatigued by the number of different websites they have had to visit. So what this does is this automatically sets for you these cookie consents so that they are, so it sets those cookies for you in such a way that it maximizes your privacy settings. So you never will need to see these cookie consent banners again. You never have to hit the accept button again. So let me maybe conclude with just showing you these different URLs, and I'll stop my presentation there.
Okay, well, thanks very much, Nishant. I think I'm certainly going to be signing up for something that deals with those cookie the cookie announcements for sure. But thank you for that. We had a number of questions that have come in, so I think we'll go straight into them. So there's one here for Giles. I think we'll start off with. In the event of a breach, what do you think is the most appropriate response by users and the company?
Thank you very much. Let's go with the glib, don't start from here.
Well,
but stepping back, there seem to be two routes which are tried by companies. One is to bury the bad news, pretend it never happened, hide away, obfuscate. Personally, and this is getting out of corporate speak into my world. I don't like that. My approach, I'm also the Chief Information Security Officer at Pexip. We try and be as open and forward-leaning as we can with our customers. There are occasions where you wish to be careful about what you disclose. So it's the usual bug issue of responsible disclosure. You find a problem in product X, plastering that all over the internet and saying there's a problem here before tapping the company on the shoulder and saying, do you want to fix this, is probably a bad idea. But as full a disclosure as possible, as full a root cause analysis as possible, and as full a follow-up and fix internally as possible is definitely the philosophy we take.
Okay, thanks for that, Giles. I've got one that's for Eerke here. Although it's slightly paraphrased from what came in the Q&A, but although UK law currently aligns to the GDPR, EU GDPR, what happens if our laws diverge? What direction do you think things would go in?
Interest is very interesting because some level of adequacy has just been decided, and the same week the UK government says, but we want to liberate our data protection law so people have more opportunities for exploiting it. And I think even in my presentation I mentioned NHSX versus NHS Digital, and they already have that sort of imbalance, that contrast between them. NHS Digital doing things more in a nice way that's is responsible, and NHS X wanting to apply AI and do spectacular things. And that tension is going to remain in UK government, and at some point it's going to be a question of are they really going to relax the rules there in order to create commercial opportunities, and will they be prepared to deal with the backlash of the EU at that point, saying, well, then actually you're no longer adequate. I mean, that becomes politics, right? I think the UK government will have learned what it meant that they didn't want to comply. They didn't want to be compliant on financial regulation. So everyone's moved from London to Amsterdam and Frankfurt now. Whether the same thing will happen in the data sector eventually, which is supposed to be a big sector for the UK. Interesting. So at the moment there is the UK GDPR, as it's called, is very, very broadly equivalent to GDPR, and the Data Protection Act 2018 is very much in line with it. But yeah, there's rumors of deviation, and it won't end well.
It won't end well. Okay, that's the takeaway message. Okay, we'll see how that pans out. This is a question actually for all of you in different angles. So maybe we'll go to Nishant first on this. But how do you see the balance between privacy and utility playing out over the coming years?
Yeah, well, I guess there's this thing. There's this viewpoint which says that privacy is like a first world problem, but it really is not. It affects everyone, and that's it's just that maybe some people see it and some people don't see it, so I think it's important to balance privacy versus utility somehow, and if it's left up to the users, they will choose utility, they will choose usability, and not privacy. So it has to be somehow pushed from the regulation perspective, which has to be pushed from the tech perspective to make it easier to enable private options to be taken. Just taking the consent management as an example, almost every single website that I visit makes it much more easy for me to click accept all than to go through one by one and pick the most private option for me. And these sort of dark patterns are not a good way to encourage privacy by any means. And so this has to be coming both from a tech perspective and also from a regulation perspective. It's not enough to just say, we give you consent. We need to enable that consent in useful manners.
Okay, I saw Eerke nodding with along to some of that. Would you want to chip in there, Eerke?
Sure. I think privacy versus utility is also ever so slightly devious way of stating it, because I think privacy preserving ways of doing things are moving on fast, which means that we don't necessarily need to lose a lot of utility. And I see that imbalance in things like do we deal with anonymized data here or not? But I think effectively it is a false dichotomy even there, because the utility of the data at some level means what you can do with it, the level to which you can use it against people, and then the question becomes where is the data, who has it? Right. The best example, coming back to apps, it is fantastic how the UK COVID app version 2 does location check-in. Right, people scan a QR code at a location, and that gets stored in the phone, and nobody ever hears anything about that unless somebody reports to the phones that there is an incident in that location. It's not being used much, but it is so infinitely better than the previous solution, which was that the bar would put a list on the bar and people would write down their name or Mickey Mouse and their phone number on it. And creepy people would pick up the phone number of the attractive person they saw in line before them and give them stalking messages, and it would still be a messy piece of paper that the bar would have no idea of how to do data governance on or deal with it properly in any sort of way. So the privacy preserving solution in that case is in so many ways superior and has exactly the same, well, has probably better utility than the obvious solution. So maybe it's not really a dichotomy.
It's a nice example. Okay, Giles, do you want to come in on that as well?
Yeah, I think it emphasizes the need for designing privacy in from day one, or security. If you try and retrofit it, it becomes a bolt-on on the side. It will be clunky to use because it's not in your main workflow. So it's making this at the heart of your software development process. I'll disagree. I'm going to be daring and disagree slightly with Eerke here and say there is a trade-off between privacy and utility. Filling in Mickey Mouse on that sheet of paper and a random phone number gives you total privacy and no utility. We have customers also who take the same approach, not quite putting Mickey Mouse on the purchase order, but disconnecting their entire system from the internet because they wish to be private. Massively reduces the utility, but that's an intentional decision on their part. So there is an intended gradient between privacy and utility, and we have to acknowledge that one. But overwhelming that vastly is the unintended gradient. So if we just fix the unintended one, we'll be in a much, much better place.
Okay. Oh, thank you all for answering that question. Different perspectives. Okay, I've got conscious of time, maybe time for one or two more. There's a technical one here for Giles. It says codecs and codec SDKs used to be a rich source of inspiration, I think inspiration in quotes, which I think means the codecs were exploitable. Is this still the case?
That's actually quite a fun question. Codecs are the pieces of software that encode and decode, hence co and dec, audio and video in video conferencing. Back in the good old days, they used to be very vulnerable to all sorts of exciting bugs. And it was mostly a denial of service type attack, as in you could blow up an endpoint or a video mixer by sending carefully framed packets at it, and everything went bang. We got better at testing, so fuzzing attacks and so forth are now much more routine in day-to-day software development. So the things have got hardened slightly, considerably. So that makes us less vulnerable. On the other side, and this is a little bit of a hobby horse, there used to be a lot of companies in the video conferencing industry doing all sorts of different things. Polycom, Tandberg, Cisco, Huawei, lots of them, all writing their own software. So if you were going to attack a codec, you would have to decide which manufacturer's codec you were after. And so you had a very limited range of targets. So it wasn't terribly, you weren't getting much money back for it because all you're doing is blowing endpoints up. And you didn't have a very rich environment to attack. With the advent of laptop-based video conferencing, more and more of that is moving to a technology called WebRTC, which was made public by Google a few years ago. And it's great. It works really, really well. But it's a single environment. So now, if you were to find a vulnerability in that, your opportunity to exploit it is far greater. So it's no longer a rich source of inspiration, but it is a source of inspiration which will provide richer gains to you should you crack it, I think. And that's not encouragement to do so.
Okay, no, that's a great insight, actually. Thank you for that. Well, I'm looking at the time now, and I'm conscious. I think that's all we've had time for. So apologies for the questions that we've not reached, but I think we've had some good discussion there and some good answers. So thank you for that. So thanks to the panel for joining and for answering the questions, and thanks to the audience for joining today. I'm going to hand back now to Andrew to talk about what's coming up next. But thank you for joining this first event in the Future of Cybersecurity session. So over to Andrew.
Thank you, Steve. And just while I shan't show my video, I'll just go that on this slide, you've got some contact details, so you can contact us at sccs@surrey.ac.uk. You can look at the website, so the university website, surrey.ac.uk/sccs, and you can also follow us on Twitter at sccs at Uni Surrey. So thanks, Steve. Thanks to the panelists. We will be making edited highlights of this session available in the near future. I'd also like to trail the second in this series, the Future of Cyber series. Will be looking at the advent of digital democracy, specifically drawing upon the Institute of Engineering Technology's recently published report on e-voting, in which Steve Schneider, Surrey University's professor of SCCS, chaired the IAT session and can guide us through some of the findings in that report, along with some invited speakers. And it's fascinating to go through that, looking at extending some of the issues that we've discussed today. We'll discuss the wider implications of being able to consult with a country's population on a more frequent basis, as is found to be the case in some countries that have e-voting. We'll also hope to explore issues such as digital influence, fake news, and the potential for digital divides that disenfranchise sections of the population. So keep an eye out for that invitation. We haven't set the date yet, but it's likely to be early June. And follow up on this website to get the edited highlights from this session. So thank you for attending. Thanks to our panelists. Thank you for this first session, and we look forward to seeing you again. Stay safe and stay well.